So today let us go with the fifth experiment. So fifth and sixth experiment are one and the same. The thing is that the concept is we have GSM and CDMA concept. We have to calculate the throughput, the implement and study performance of GSM on NS2 using MAC layer. So here we are just creating an environment of 2G network for a GSM. The topology is very simple. Though we will not achieve the complete scenario, we create an environment of 2G network here, 2G technology using GSM, using NS2. Okay. So here is the construction of the topology. We have a sender. This is a mobile node and this is a destination. This is also one of the mobile node. In between, we have many base stations. We have considered 2 base stations. Okay. Base station 1, base station 2. To connect in between the base station 1 and 2, we have a mobile station, right? So you can see the topology. So we'll directly go to the NS2 as there are many modifications on the code has to be done. Okay. So let us start NS2. So here you go to the wide scenario. Once you click the wide scenario, take the nodes N0, N1, N2, N3, N4. So N0 and N4, N0 is a source, N4 is a destination. As we have seen in the diagram, N1 and N2 are the mobile stations, right? So you could see here, this is a source, this is the destination. In between we have a base station, base station 1, base station 2. That in between base stations, we have a mobile stations to connect. We can have so many base stations in order to in between assets. For our topology, we have taken this is base station, this is base station, and this is a mobile stations. So let us have a link in between the source and N1, that is one mobile station. Okay. Again N1 to N2, N2 to N3, N2 to N3, N3 to N4. So we have this. So since N0 is a source, we will connect to the agent TCP, this TCP agent. So we can have many TCP agent to the same source. Okay. So I'll connect one more TCP agent. Then take a sync at the destination. N4 can have multiple syncs. N4. Okay. Then you can connect this sender with this destination connected. Again, I can connect this TCP1 with one more sync we have. So this is finished. Now you have to connect with the application at the sender, that is TCP, FTP here, FTP here. So this itself is a topology that you have to draw resembling one of the environment for this, right? So this is a sender, this is a receiver. In between we have base stations and mobile stations. So we'll set up the bandwidth and the queue size. Go to the links again. So in the link, you could see in this link, we'll set up 3 Mbps. Similarly, in this setup, one, N3, done. Now what you have to do is you go to the parameters. So save by the name. So s5.trace, this will be generated, and nam file will be s5.nam. Done. Then we'll generate a TCL scripts. So TCL scripts will be generated. Now you could see this is a very simple TCL scripts. So you have to save by these scripts. So there are many modifications as I said. So that we will do it in gedit. Okay. So you have to be very much carefully note the modifications that you have to do in this. I'll explain in very simple manner so that you understand. Save this TCL scripts by the name simulation s5.tcl. I have saved it. All my nam file is s5.nam. So s5.trace, s5.tcl scripts. I have saved it. I'll close this. Now once I close, I'll go to the gedit s5.tcl. Okay. So what all the major changes that you have to do? I'll just see there are set of modifications that you have to do. That is adding the general parameters and link properties. So we have to add in this simulation parameter setup. So we'll increase the simulation time to 50. First modification. So just to show you, this is the first modification. Next, what you have to do is you need to add few of the general parameters. So I have already the few general parameters I have done for the experiment. So what all the general parameters that you have to add? These are all the few general parameters and link parameters. So I'll explain this general parameters, what exactly it is, once I complete this setup. Okay. You add this in the simulation parameter setup. First change. Okay. Then what you have to do is next modification. Next modification, you come to the node definition. See in the node definition, what is being s5.tcl, what is there in the node definition? So it is all n0. We have set n0, n1, n2, n3, n4 no. So what you have to do is you modify this by nodes like this, nodes, open the bracket, close the bracket. This is the conventions that you have to follow for GSM. Nodes followed by $ns node. So again, this is also nodes. Got it? Set nodes. Instead of set n1, you have to set nodes of bracket n0 as such. Okay. So I have done the modification. So I'll just replace this. Second modification, replace instead of set, okay, replace by nodes of n0. Instead of n0, replace by nodes of n0. Next modification, in the link definition, what you have to do is so you have to create a procedure called topology, cell topology, and all n0 should be replaced with nodes of n0, and you should remove the Q limit. Okay, let us remove the Q limit. See, delete this. We don't need Q limit. That's why in the link setup also I didn't do change the Q limit. Now see, what you have to do is you have to write these link definitions within the procedure called cell topology. So I'll show you that. Before that, what are the changes here you have to do is $ns duplex links. Okay, dollar is there, no, it should be replaced by nodes of n0 bracket. sorry, and dollar nodes of n1. Wherever n1 is there, you replace by dollar nodes of, like this. Okay, use a drop tail. So all these things have to be done in the same way, and it has to be written within the cell topology, and you should name as a print statement called cell topology. So I'll just show you that how we will do it in the link definition. What you have to do, you have to call a procedure cell topology, open bracket. So within that you have to write global ns nodes. Okay, globally you have to record the ns nodes, ns as nodes. Okay, so what are those nodes? Here we have meant nodes of n0, nodes of n1 here, and you, it is a simple printf statement puts. What is that? It is a cell topology. I'll just add this. Okay, see, in the s5.tcl, what I did is, so within the procedure cell topology, open the bracket. So what you have to do, globally you have to declare ns simulator for nodes. So these nodes are been replaced with same link. Instead of n0 was there, nodes of n0 was replied. Remove all the q limit, then you print this as a cell topology within these brackets. Then you have to write a set parameters. Okay, you have to set parameters. So I'll tell you that. So you need to see, it is quite easy, just you have to analyze. Don't find it a difficult, that it is a difficult task. You write a procedure to set link parameters. So what is t? I'll tell you, it is a gsm. Let's copy. Procedure sent link parameters of t. So what is t? I'll tell you exactly right now. T is for gsm, t resembles for gsm. So we are setting globally using ns nodes bandwidth up limit, bandwidth down limit, propagation up limit, propagation down limit. Okay, so downlink, uplink, DL represents downlink, uplink, bandwidth downlink, propagation downlink, and we represent the Q limit also. Okay, for in between, same as if like N0 to N1, N1 to N2, N2 to N3, N3 to N4. That is a buffer of GSM. $T represents the GSM here. Okay, so this is to set the globally the NS nodes bandwidth up limit, down limit, propagation up limit, down limit, and buffer limit. Once you do this, next you have to, very important thing that you have to do is, so this is within the bracket, remember, procedure set link parameters, open the bracket, close the brackets. Here what do you set? You set all the up limit, down limit, right, with respect to propagation delay, with respect to bandwidth, and with respect to buffer. Similarly, in this cell topology, what you do, right, you write the globally as ns nodes. You say that it is a cell topology. What is that cell topology? We'll see. Okay, importantly, this is important, that is, you will create a switch statement option type called cell topology. This you have to add. So what it does, so in the downside, see what it does, switch option type. This is the common statement you write for all sorts of programs, saying that switch option type. Which is the option type? Whether it is a GSM, GAPRS, or UMTS. UMTS is for what? For CDMA. GSM for this existing. So as you have seen in the initial beginning, we have common parameters. We have taken GSM. Okay. So you use a switch statement option type. Here it will automatically switch over to either to GSM, GPRS, UMTS for the value T. So how it switch overs? It switch overs from the beginning, as in the initial parameter, what you have mentioned, set bandwidth to GSM, bandwidth up limit to downlink, uplink GSM, propagation delay to GSM. All the value T is automatically taken here. The value T which you have taken is automatically set to GSM from this switch statement. Option type is switch, no? So for GSM it will set, and here T represents the switch. Switch from the switch statement, T resembles the GSM. Then one more major thing that you have to do is in agent definition. In the agent definition, you have to use selective acknowledgement. So in the TCP connection, so you have TCP0, TCP. So here also you have to modify wherever $N0 is there, you have to modify $nodes of 0. Okay. $nodes of, this is the modification you have to do. Similarly here also $nodes of N4 to wherever dollar is there, we have replaced with the nodes. Okay, N0, N1, wherever is C, nodes of N0, nodes of N4, nodes of N4, here also nodes of N0. Done. Now you have to add wherever TCP sync is there, you have to add SAC1. So selective acknowledgement. So you have to write SAC1, selective acknowledgement 1, wherever sync is there. SAC1. So this is done. And we have shown you the modification this. Then you have to see here NS-FTP. So we'll modify 1 to 35 and this 1 to 45. 1 to 45. So this is the maximum modifications we have done. The first modifications globally, we have general parameters and link parameters. So I'll send this the document. So general parameters, to set the option type 0 start and stop time. Then regarding the topology, it is a GSM. This is very important. And you have to represent the average delay access length. Then what is the threshold? So what is ECN? So the ECN means explicit congestion notification. Okay. So what is AQM? AQM represents an active queue management. Here we set the threshold, maximum, minimum threshold, maximum threshold. Then we continue with the traffic generation. Okay. Number of web sessions, number of window. Then we will set the downlink all for GSM. T all represents the downside. What we have called is for GSM. We'll set the uplink, downlink for with respect to the propagation delay, bandwidth, and the buffer. The same thing in the node definition will replace instead of N0 nodes of N0. Second modification. Third modification, you call the processor set topology, will remove the queue limit and globally NS as nodes, cell topology you call. Then you call the procedure to set the link parameters of T. T represents the GSM. How it takes switch option type. So option type T looks for GSM here. So automatically this switch statement switch over to the GSM in order to set the up limit, downlink, uplink of bandwidth propagation delay. Now I'll save the file. Save the file. And we have awk file also. Okay. So awk file is to find the throughput. Okay. So that is a trace file will be generated when you run that 5. NS5.TCL. So awk file will be generated. So you have to count the throughput, that is $1 whenever it is received, and $5 the type of packet is TCP. Count the number of packets. Okay. So print the throughput calculated in Mbps 10 power 6. With respect to the, also you need to calculate the time also. See, packet $6 has to be counted. Once you find this, now let us run the simulation. NS S5.TCL. So we have line number 114. So what is the mistake that we have done? So that is in switch statement. Let us see. The delayer. So in the link definition, error is showing here. Switch. See this, we have to eliminate this. We don't need this. So same thing has been modified, right? Clear? So now save. Clear? Hopefully understood all of you. So this is a switch statement to say which is the option type to switch over. It is GSM. Once it gets switch over, T will be copied over here. That is GSM. All the GSM bandwidth uplink, downlink, propagation, uplink, downlink, buffer will be set from the initial parameters. That is the general parameters we have set. So now we have got. So simulation we have done for 50. So I will not run for that much. Our objective is totally to see the I could see the stations. These are the like acknowledgement that is being coming out. You could analyze this, all of you. Why I have taken 50 is just to analyze the selective acknowledgement, how it is being reached at the destination and all. So let me stop the simulation and let me calculate the throughput. Stop the simulation. So as I've seen, shown you gedit 5.awk, you have to calculate the throughput that is in Mbps to count the number of packets that is matched in the TCL script. So I'll show you the TCL script gedit. So we have seen this s5.trace. So you could see in the trace file wherever it is read and wherever we have a packet T $1 and 5, match it, and you know you have to show okay, this is the ACK file. You have initialize count time pack to 0 $1 and read $5 equal to TCP. You have to count, calculate the packet, that is a packet size and the time. So this is the throughput you need to calculate using the formula, that is dividing the number of packets divided with the number of time to give the throughput value. Okay, now run the awk file, awk -f. So our simulation file is s5.tcl to s5.trace 5.awk. Sorry, I did a mistake with the awk file. So first you have to put awk file -f5.awk followed by, so I have saved by the s5.trace file. So you could see the throughput is 3.02718 Mbps. This itself is an experiment. So try to analyze the experiment topology. Is the easy thing is that the modification what you have to do, that is very much important. So I'll share the video. You just see the video and try to understand.